In this video, I want to look at a specific example where we can patch up a failed U substitution through a technique that is sometimes called inverse substitution. So I want to start by looking at this antiderivative. I want to look at the antiderivative of x over 1 plus x dx. Now, this is something that it's tempting to say, why don't we try something like u is equal to 1 plus x, and du, of course, would simply be dx. And if I use this particular stuff to rewrite the integral, I will get this kind of stuff. The dx, of course, is just equal to du, and the bottom, of course, is just equal to u, but we still have this silly little x running around. And now we know from past experience that once we do a u substitution, all of the x's should disappear, and they didn't here. So what we're going to do is we're going to have to think in terms of, can we patch things up? Now, this does not always work, but sometimes when our u is a very simple linear kind of a function like this one, or sometimes it'll even work with a very basic algebraic one, I can solve this particular equation for x. And that's what I'm going to do right now. I'm going to write it down here that u equal 1 plus x is going to tell me that u minus 1 is equal to x. And I can put this particular fact in for this particular x, and I will then have an integral that I can actually do. So when I do this particular set of substitutions, putting this last little piece in, I wind up getting an integral that now looks like u minus 1 over u du. This integral is now completely in terms of u, and fractions can be broken up at plus or minus signs in their top, even though they cannot be broken up at plus or minus signs in their bottom. So it is legitimate to write this particular integral as the integral of u over u du minus the integral of 1 over u du. Well, neither one of these are very difficult. This one here is just a fancy way of saying the integral of du, and I'm going to just leave that one as is right now. And now we're going to do the integration. The integral of du is just u, and the integral of 1 over u is the log of u. And I have that minus sign that connects these two things, plus any constant that I want to add. Now, to get back to x's, it's a matter of doing nothing more than recognizing that u is equal to 1 plus x. So we're going to have 1 plus x minus the log of 1 plus x plus any constant that I want to add. Now, this is one that is tricky enough where it is worth doing a check. So I want to do the check on the next page. This is our check. I want to look at the derivative of our answer, which was 1 plus x minus the log of 1 plus x. And I want to see if I get the integrand. Now, I want to kind of remember that the start of the problem was finding this particular integral. So that is our target, is to get x over x plus 1. Now, this derivative is not very difficult. It's going to be the derivative of 1 plus x minus the derivative of the log of 1 plus x. And this one is a pretty simple derivative. That's just going to be a 1. And then we have a very easy chain rule. The derivative of the log of junk is 1 over the junk times the derivative of the junk. but the derivative of that junk is just a 1. So we are now looking at 1 minus 1 over 1 plus x, which symbolically looks different than the integrand that we started with. The integrand, of course, here is just x over x plus 1. But what I'm going to do is I'm going to do a little bit of algebraic simplification. If I want to write this as one fraction, I have to put it over a common denominator. And the common denominator is 1 plus x. And to get 1 over 1 plus x, I have to multiply it by 1 plus x. And then I have minus that 1. And once I simplify this, I'm looking at 1 plus x minus 1 all over 1 plus x. And 1 plus x minus 1 is just an x. And hence, we actually do have our check because this is indeed the integrand of the problem that we started with.